I'm going to briefly explain how to use an interactive simulation that uses the van der Waals equation of state to generate phase diagrams. And the idea is that we're going to look at pressure volume diagrams and temperature volume diagrams. The simulation is located at this link. Let's just look at a snapshot of the simulation. So here's the log of pressure versus log of volume. That's important. The blue line represents this cubic equation of state, including the blue dashed line here. However, this doesn't correspond to physically meaningful conditions. And instead, in the two-phase region, we have these two orange dots that the volumes are shown here, and they connect the liquid that's in equilibrium with the vapor, and their location is determined by having the fugacity being same for the liquid and the vapor. If this were a linear plot, linear pressure, linear volume, then this green area would equal this green area, another way of determining if the fugacities are equal. So the simulations allows you to change the temperature, and you'll see when we look at the simulation how this changes the blue line. We also can look at a temperature volume diagram by selecting this button here. So let's look at this simulation. So here you can see on the simulation, if I use the slider to change the temperature, then of course the volumes change, the pressure where we have phase equilibrium goes up as the temperature goes up, and if we raise the temperature enough, when close to the critical temperature, but we can go above the critical temperature, then there's only one phase that can exist. If I look at the temperature volume diagram again, the volume is on a log scale, and now as I raise the pressures, so what we're looking at now, the blue line is an isobar. Again, as I raise the pressure, I raise the temperature, we have phase equilibrium, and I can raise it enough, of course, that we're in the two-phase region. We don't have the areas highlighted in green for the temperature volume diagram because they don't have any meaning, any physical meaning. So this simulation shows that just using a cubic equation of state, we can actually not only generate conditions given, say, pressure and volume, what's the temperature, given temperature and volume, what's the pressure, but we can also generate the conditions for phase equilibrium, namely given temperature, what is the saturation pressure, given pressure, what's the saturation temperature.